Imagine for a second you have to find one person, totally lost in a huge remote area. You can't see them, you can't hear them, but what if you could detect the one thing that proves they're alive? Their heartbeat. From an airplane flying 64 kilometers away. Sounds like science fiction, right? Well, today we're going to unpack the mind-bending quantum science that made this exact scenario a real-life rescue mission. Let's just start with that single number, 64 kilometers. That's about 40 miles. From that distance, in hostile territory, U.S. forces were reportedly able to detect the heartbeat of a single downed pilot. I mean, this is a feat that until just recently belonged firmly in a Hollywood movie script. So the big question is, how? How in the world do you isolate the faint, almost non-existent magnetic whisper of a human heart from that kind of distance? Well, the answer involves a century of physics, a really strange quantum trick, and a tiny, perfect flaw inside a diamond. To solve this mystery, we're going to follow the scientific breadcrumbs. First, we'll dip our toes into the bizarre world of superconductors. Then, we'll look at the quantum junction that lets electrons do the impossible. After that, we'll see how a diamond gets a quantum sense, how AI learned to listen for a heartbeat, and then we'll walk through the rescue itself. And finally, we're going to ask, what does all this mean for the future? What happens when your own heartbeat becomes your ultimate ID? Okay, let's start at the beginning with the foundational physics. Our story actually kicks off over 100 years ago with the discovery of a super weird electrical property, one that would eventually let us read the magnetic field of the human heart. So first, a super quick refresher. You know, in any normal wire, like a copper cable, when you push electricity through it, the electrons don't just have a free-for-all. They bump into stuff, they create friction, and they lose energy. That's called resistance. So if you put 100 units of energy in one end, you might only get 98 out the other. But then, in 1911, a scientist named H.K. Onnes found something absolutely wild. If he cooled mercury down to an impossibly cold negative 270 degrees Celsius, all that resistance just vanished. Poof! It became a perfect conductor, a superconductor. Now let's fast forward about 60 years. By the 1970s, doctors realized this amazing property could be used to build a sensor so sensitive it could actually detect the incredibly weak magnetic field generated by our own hearts. Now, this is where things get really interesting. Let's see how scientists took that basic idea and, using a very strange quantum effect, built something that was exponentially more powerful. So to build the world's most sensitive magnetic sensor, it's called a squid, by the way, you basically follow these steps. You start with a regular conductor. You supercool it so it becomes a superconductor. Then you do something that sounds crazy. You create what's called a Josephson junction by putting a tiny insulator, a barrier that shouldn't let electricity pass, between two of these superconductors. And then you link two of those junctions together in a loop. And that is a squid. Okay, here's the crucial part. In our world, a wall is a wall, right? But down at the quantum level, the rules get weird. Thanks to an effect called tunneling, electrons can basically just teleport across that barrier, something that should be impossible. This quantum leap is what makes the squid so incredibly sensitive. Any tiny fluctuation in a nearby magnetic field, even one as weak as a heartbeat, causes a measurable change in the squid's electrical current. We had finally built a device that could turn a magnetic whisper into a clear electrical signal. The squid was an absolute game changer, but it had two massive problems that made it useless for any real-world field use. First, it only worked at that insane negative 270 degrees Celsius, which needs all this bulky, complex cooling gear. And second, the person being measured had to be perfectly still. Yeah, not exactly practical for finding a soldier out in the mountains. And this right here brilliantly illustrates the leap that made our whole rescue mission possible. Scientists needed a totally new kind of sensor. They needed something with all the sensitivity of a squid, but it had to work at room temperature and be small enough to slap onto a moving drone. The answer wasn't in some exotic metal, it was in a gemstone. The solution was to create a lab-grown diamond with a very specific intentional flaw. So in the diamond's perfect grid of carbon, scientists swap out one carbon atom for a nitrogen atom, right next to a deliberately empty space, a vacancy. This little imperfection, this nitrogen vacancy center, or NV center, creates a tiny quantum system that's extremely sensitive to magnetic fields. But, and this is the whole ballgame, it works perfectly at room temperature. So, this new diamond sensor was portable, it could work in the heat of a desert, awesome.
But it faced another enormous challenge. The world is an incredibly noisy place, magnetically speaking.
See, the challenge is that this NV sensor is so sensitive, it picks up everything. The Earth's magnetic field, radio signals, power lines, any other animals nearby, you name it. A human heartbeat is this tiny, tiny signal buried in an absolute ocean of magnetic noise. So how could you ever possibly pick it out?
And this is where AI enters the story. Researchers trained a specialized AI to recognize the unique magnetic signature of a human cardiogram. It's basically an expert at noise cancellation. Think about it this way. Some AIs can now figure out what you're typing just by listening to the sound of your keyboard. It can isolate that one tiny sound from all the other background noise. This is the exact same principle, but for a magnetic murmur.
All right, let's get to the tactical application and see how this incredible combination of diamond sensors and artificial intelligence pulled off something that sounds like it was ripped straight out of a spy movie. So here's how it all came together. Drones were equipped with those portable NV diamond sensors. These sensors fed a constant stream of magnetic data to the noise cancellation AI. As the drones flew over the target area, the AI was just listening, filtering out billions of unwanted signals, hunting for that one specific pattern. And once it got a lock and confirmed a human presence, a rescue team was sent to the exact coordinates.
And just to put the sheer difficulty of this into perspective, think about the scale. The magnetic signal from a heart is measured in femtoteslas. That's a quadrillionth of a Tesla. Finding that from 64 kilometers away, it really is like trying to find one specific grain of sand in an entire desert. So the technology works. It's been proven in the field. But this brings up a much, much bigger question. What happens next? What are the profound future implications of being able to detect and identify a person by their heartbeat alone? You know, it might be surprising, but just like a fingerprint or the iris of your eye, your heartbeat is totally unique. The exact rhythm, combined with the strength of the heart's muscle, and even your body composition, all create a distinct magnetic signature. No two are exactly alike. So an AI that can find one human heartbeat in a desert could definitely be trained to tell the difference between yours and mine. Which leaves us with this final, really provocative thought. We're entering a world where a unique, involuntary biological signal can be read from a distance without you even knowing it's happening. So what happens when your very own heartbeat becomes the ultimate, undeniable form of identification? It's a question with both incredible promise and profound consequences.